Hello there my science friends and welcome back to my channel. It is the time of the year again where we as science enthusiasts ask ourselves what a resurrected dude from 2000 odd years ago has to do with bunny rabbits and eggs. But we all enjoy the holiday break that comes with Easter, so let's grab a cup of coffee and dive right into the chemistry of dyeing Easter eggs. By the way, this video is kids friendly and has some DIY advice in it. So feel free to bring them along for the ride and replicate the chemistry in your kitchen. Alrighty, let's start with the base needed for our colorful Easter display. The egg. Eggs are one of the most versatile kitchen ingredients, if you're not vegan that is, as there are numerous ways of cooking or baking with them, or even just preparing them on their own. But what are they made of? And what do they have to do with the smell of rotten eggs? Let's have a look. Egg chemistry. Let's start from the inside out. The center of the egg is the egg yolk. Its yellow color comes from the carotenoid proteins lutein and zeaxanthin. These two molecules result in a slightly fade yellow color. But some eggs have a bright yellow egg yolk when you crack them open. How can that be when artificial additives are not permitted in chicken food? Sometimes other natural additives such as beta-carotene or marigold petals are added to the chicken feed and influence the egg yolk color naturally. The yolk is surrounded by the egg white. About 90% of the egg white is water. The remaining 10% or so are mainly made up of the proteins ovalbumin, conalbumin and ovomucin, amongst others in the following ratio. Ovalbumin is thought to be the nutrition for the developing chick. Ovomucin helps thicken the egg white, and conalbumin binds iron and guards the chick against infections. These proteins in the egg white also come into play when an egg is cooked. Egg proteins begin in the raw egg as folded chains. But when they are heated up, for example in a hot pan, they begin to denature and unfold. These unfolded protein chains are a lot like cooked spaghetti. The interactions between them create a three-dimensional network trapping water and causing the egg to solidify. Ta-da! We made scrambled egg. Those proteins in the egg white are also the source of the rotten egg smell. They contain sulfur, which can react, for example, through cooking or boiling an egg, and form hydrogen sulfide, which gives cooked eggs their characteristic smell. When eggs aren't used for a long time, hydrogen sulfide is produced in a higher amount through bacteria in the egg, giving them the typical rotten egg smell. But how do you know if an egg is fresh or old? You can test this easily by the so-called float test. Put your egg in a glass of water. If the egg sinks to the bottom and lies flat on the side, it is fresh. If the egg tilts upwards or floats, it is an old egg. This is due to the little air pocket trapped inside the egg. As the egg gets older, this air pocket inside is getting bigger as water is released and replaced by air inside the egg. And the bigger air pocket wants to rise in the water and make the egg float. It also makes a difference if your egg is old or fresh when peeling it after boiling. This has to do with the pH. The egg white pH of a freshly laid egg is about 7.6 and gets higher up to a pH of 9.5 after several days of storage. Why does this happen? As the egg gets older, CO2 diffuses out through the shell. This increases the pH inside. The egg white, however, adheres stronger to the shell at lower pH, which makes fresh eggs harder to peel after boiling than old eggs. Okay, enough about the inside of the egg. What about the obvious part, the shell? Eggshells contain mainly of calcium carbonate. If you watched my video on fluoride in toothpaste, you already heard about this. But eggshells are not just calcium carbonate rocks. They actually consist of calcium carbonate nanoparticles, which are arranged in ordered crystal structures by eggshell proteins, forming a so-called calcite shell. The color of the eggshell comes from different porphyrin pigments on the egg's surface. Right, now how can we get those white Easter eggs colored? And how can you do this right now with things you can find in your kitchen? All the veggies of the rainbow. Colorful eggs are a great Easter tradition. But you don't always have to run to the shops and get those Easter egg coloring packs with those dye tablets. Let's have a look at the chemistry and how you can do this in your own kitchen with ingredients that not only look good, but also taste good in the process. First up, the dyeing process. When you want to dye eggs, it's not enough to just throw them in a glass of dissolved dye in water. Commonly you have to add about 1 tablespoon of vinegar. But why is that necessary? The proteins in the calcite shell on the egg end in so-called amine groups. An amine group is a nitrogen which has 2 bonds to hydrogen. The third bond is to the rest of the eggshell, and it also has an unshared pair of electrons sitting on it. The added vinegar is a weak acid, which means it releases hydrogen ions which interact with the amine group of the protein and attach to the unshared electron pair. It protonates it. The cuticle is now positively charged, which makes it easier for the negatively charged dye molecules to stick to it, making the color of the eggs after dyeing more intense. This process gets even more intense when the water you submerge your egg in is warm or hot. Now, what about the colors? Let's go across the rainbow and see how we can get all the colors from everyday ingredients out of your kitchen. Purple or blue. The color comes from pigments called anthocyanins. Depending on the pH, so the amount of added vinegar in the solution, they can appear as pink, purple or blue. The more vinegar you add, or the hotter the water is, the more pink the color becomes. You can make your own coloring dye by boiling red cabbage or blueberries in a pot of water until it has a dark purple to blue color. Green. Green color comes from chlorophyll that you can find in almost everything green in your fridge or garden. You can use spinach, parsley, nettles or simply grass. Just make sure you sieve it well before using it as dye for your eggs. Yellow. To color your eggs yellow, you can boil in the skin of a few white onions. They contain pigments called flavonols. Make sure you don't use red onion though. They contain anthocyanins as well as red cabbage and would color your eggs purple instead. Orange. For a bright orange color, carrots could be used due to their high amount of beta-carotene. If you would rather eat them or feed them to Easter bunnies, you can also use turmeric instead for an even brighter yellow color. Just mix it with water for your yellow dye solution. The yellow hue is due to the compound curcumin. Red. Red color comes from pigments called betannins. You can make your own red dye by boiling red beetroots in water. If you want to know more about beetroots and why you should eat them too, watch my video on that power vegetable. Rose. Now, for all my Melburnian friends, here's an extra special coloring tip. To get your Easter eggs rose colored, boil avocado cores. The tannins in the seeds and skin of avocados give a lovely faint rose color. All of this is also a really good way of reducing food waste, and get creative in case you're stuck at home over the Easter holidays with your kiddies due to the naughty C word. So go ahead and show me your colorful Easter baskets on YouTube or on the socials. Don't forget to tag me. Do you have any more DIY natural veggie Easter egg coloring recipes? Write them in the comments below. Now go and have a good Easter break. I'll see you again in 2 weeks. Until then, as always, stay sciencey.